In this video, we're going to do another normal probability example. So in this question, the length of eels in a river is normally distributed with a mean length of 20 inches and a variance of 4 inches squared. What is the probability that an eel caught in the river is between 18 and 21 inches? So again, I recognize this is a normal distribution, so x is distributed as a normal distribution with mean equals 20, and it gave us variance, so I need to convert to standard deviation, so square root of 4 is 2, so sigma equals 2. And now the question, of course, is what's the probability that an eel caught in the river is between 18 and 21 inches? So the probability that 18 is less than, and if you want to put equal to, that's fine, x less than, again, equal to is okay. Because this is a normal distribution, it's a continuous distribution, the equal to is irrelevant. So the probability that 18 is less than x less than 21 on the calculator is 0.532807. 2082, and of course that's going to round to about 0.533. And of course on my calculator I typed this in, normal CDF, that was my lower, my upper, my mu, and my sigma, and that's how I got this number. Now again, I wrote the long version and then the 3 sig figs rounded for the final answer, and I'm going to need the long version for part B. So now, given that an eel caught in the river is between 18 and 21 inches, what is the probability that it is at least 20 inches long? So I'm in the same distribution. We're still only pulling one eel out of the river. So it's a random, normal distribution here. And we now know that the eel had a length between 18 and 21 inches. So that's given. In fact, it uses the word given. And now the question is, what's the probability that it's at least 20 inches long? Again, this is a conditional probability question. I don't have to write x is distributed as a normal distribution anymore because it's the same normal distribution, but I do need to write the probability statement, which is the probability that x is at least 20, so greater than or equal to 20, given that 18 is less than x, which is less than 21. Now, because this is a conditional probability question, I need to do the probability of the intersection of these two divided by the probability of the new sample space. So that's going to be the probability that x is greater than or equal to 20 intersect with 18 less than x less than 21 over the probability of the new sample space, or the probability of the given, which is 18 less than x less than 21. Now I already have the denominator probability because that's what I calculated over here. I now need to work out the numerator, but I need to figure out what is the intersection of these two regions. Well, I know that x has to be greater than or equal to 20, and then it's going to be capped at the top by 21. So really this is between 20 and 21. So I have the probability that 20 is less than or equal to x, which is less than 21, over the probability that 18 is less than x, which is less than 21. Now again, the equal to is not critical here because it's a continuous distribution or a normal distribution, therefore equal to or not equal to is not going to change anything. So now I can plug this in the calculator using the normal CDF. The lower is 20, the upper is 21, the mu is 20, and the sigma is 2. And then this one I had from the calculator earlier, and of course keep the long decimal version. And when I plug into the calculator, and I can round this now to 3 sig figs because the final answer, I get approximately 0.359 as my final answer. And that is the end of the video.